Hey guys, and welcome to Fully Defined. My name's Chris. I'm a certified SolidWorks expert. In this video, I'm going to take you through my design process to develop and 3D print a neat bracket to fit under my desk to hold my headphones. I'd love to show you more real design projects, but there's an obvious challenge in that a lot of the work I do is confidential and not for public consumption. So I think the next best thing is to show you some of the similar processes, but on a project that has no problem with public disclosure whatsoever. So in this video, some of the topics we'll cover is taking dimensions of some important features. Some of the SolidWorks tools that I'll show you throughout the project include boss and cut extrudes using the replace face tool. It includes the example of a cut sweep, shell using delete face, and some varieties of fillets. Let's jump in. I'm going to bring you along on a little project that I'm about to go through to finally work out what to do with these. I've got a new desk. I've got laptop up top for work. I've got a PC tower underneath, built under the desk. I'll flip under there and I'll show you that problem. So you can see here, I use these headphones for gaming and other stuff on my second computer. They're plugged in via USB. I quite like having this sitting here, but it's not the perfect edge for it. This desk goes up and down, so I do want to have something attached up here. So what I've decided to do is use a couple of screw points here. So we've got 3 screws. I'm just going to design a little bracket that's going to slot in here under those screws, or even have the screws go through it. Just come down with a little L shape so I can hang these headphones right here under the desk and get them out of the way. So let's go through that now. And I'll show you the process of how I do that in SolidWorks and send that to the printer. We'll do a bit of work both on and off screen. We'll start with a new part, and I think I'm just going to do an L shape or kind of a U-shaped bracket with a couple of screw holes at the top. So it's not going to be like overly complicated or fancy. It's not something that's going to be visible. I just need to be functional, which means kind of need to be strong. So let's just draw the rough shape. And how big do I need for these headphones? Well, about this big. It's about 40 millimeters. If I get the calipers out, I can see that it's turn on, please. The distance is 33.5. So if I've got something that's like a nice little arc that's around 40 millimeters, that'll work pretty well. So let's just make that for construction, and let's just put a little one in here and give that a dimension of 40. Okay, and we'll just give that a bit of an arc too, just dimensional like that. The height that I need, I just need to have enough clearance so that when I bring it in and lift it up and drop it down, I'm not hitting the top here. Okay, so if I give it this sort of clearance here, that's probably enough. It's probably about 80 millimeters. So 60 millimeters even, so it doesn't need to be that big. Right. So that's going to be on the inside face. Let's go 60. And then this is the important dimension. So this is where I'm going to measure those holes, okay, and try and get that pretty accurate. Let's just start with a 50 mil. And like, how wide is this going to be? Well, it's going to be determined by the spacing of those bolts. So there's 3 bolts under there, and I'll show you in a second. I'm just going to start this with an extrude feature. I'm going to do a thin feature. Let's just make it 3 millimeters to the outside. We'll go mid-plane. I'm just going to suggest it's 60, but now let's go and measure that underneath. Let's see if we can get in a little bit closer. 1, 2, 1. Okay, you can see the 3 screws here. So I've got one at the front, one that comes straight back here, and then another one to the right. Okay, and we want to get, if I just put 2 screws in a line, well, that might have a bit of weakness to it potentially. So I'm just going to play it safe and just do like a nice plate here that's going to cover all 3 of those screws and give me 3 fixing points for this. So I can take one of those screws out and I can measure the screw, and that's going to give me the size of the hole that I need. If I take one of these out, the time is perfectly fine. These screws here are just holding a plate, and there's another 3 screws holding it right now, so I'm not concerned doing that. So this screw is batteries run out of the calipers. You sus. This screw is an M5. It's an M5 screw. Yeah. Right. So M5. So all my holes I'll just make a little bit bigger than that. I might go like 5.5 millimeters. And you can see here that I could potentially just loosen all 3 and have something that slots in, which might be, if we can do a design like that, might be a lot easier just to get on and off if I need to, let's say, make a revision or change your hole size. So even in that gives me the idea that with these ones on the underside here, I could just slot straight in. So if I lifted it up and slot it down, up and in, that's going to work quite well. I need the distance between. So I'm going to measure center to center. We need some whites. That's what we need now. Let's try this out. Okay, that's a bit better light. Now, I'm going to go ahead and measure the distance between those two. And I'm using center to center. And I'm just doing it by eye with the sample calipers. I get 46 millimeters. And I'm not worried if I'm off by half a millimeter or something because it's a 3D print. It's 3D. I'll just reprint each fumble. So 46 millimeters that way. Now these two are not level. This one is back a little bit further. So I have to account for that as well. And then these two here, it'll be a similar thing. And at center, that is, let's say 78 millimeters. Okay, so 46 and 78. So already the part that I've designed up top here, well, that needs to be bigger than that. So let's go out to 90. And what do we say, 46? It's going to be 60. Right, so let's put those holes in. And to make sure we've got space from this side wall, let's do it on this face underneath, because this face isn't changing. Let's put our holes in as 5.5 for all three, and we can change them into a slot later. Yeah, let's look at that from a side view or from directly underneath. Make these two vertical, and what did I say? 78, and then these two 46. Yeah, that's one. This one here, let's think about this for a second. I've got an edge here. Just going to convert that so visually I can just see where that edge is. So this 78 millimeters, if I put a construction line between those two, I can then put another construction line in to make sure that those remain centered, right? And then this 46 dimension here, if I want those to remain centered on the top as well, can do a similar thing. Construction line, I make that for construction, and then use this midpoint here to go to this midpoint and make that one vertical. All right. So now whether this moves up or down, that's not really going to have an impact. So that's giving me my space. Now there's plenty of room behind this one and behind this, so that if my thing is bigger, which it is, it'll be all right. It's this screw that's all right, that sits back more. But if I have a look at that distance now, from the underside view, just eyeballing it with the help of the calipers to roughly get center to center, it's about 9 millimeters. Okay, so that's going to help even more. I think I have to bring the whole object apart. See how wide this is. I'll think here's like 115. So if I make it even longer than what it is currently, that's probably okay. So what did I say? 9 millimeters? Then we want to make the whole thing bigger. Let's go 110. All right, looking good. Now, if I wanted to check these holes, without doing the 3D print, I can just print it on a piece of paper, put the slots in, and just measure it and just see how it fits. And I think that's probably a worthwhile idea for this, because the print, because it's actually a bit bigger than I thought, the print will probably take a little bit of time. So let's do that. All right, so 9 millimeters was right. Now, these holes at this point are looking good. I'm just going to cut them. I can always change to a slot later. It's going to go through all with a cut. Now I can think about things like screw head clearance, right? So that the screw that's used, there's a washer and then there's a screw head. The washer's biggest, and the washers are around 11 millimeters. So around each of those holes, I've also got to have, let's make it like 12 millimeter clearance, right? So 12 and 12 and 12. So I'm making 3 holes here. They're all equal. They're all for construction. All right. And you can see that's clearance is okay. That's okay. So no problem with those. Let's save this part. Headphone holder V2, because I have made one before. But this is in a different location, a different position. All right. Now, assembly. Can we slot it in? It's 3 millimeters. So I want to here check the screw to see the gap that I can get if I loosen it between the washer. Yeah, I'm just looking at the gap here between the washer and the screw head. I'll just show you on this video. You see this distance here. Okay. So if I'm going to slot above that, it's a split. There's a split washer there as well. So split washer, flat washer, screw head. I want to make sure I get 3 millimeters in there, which I can. Okay, so 3 millimeters is okay. Now we think about the way that that's going to come in. Well, let's do a little example here. where I'm going to use this sketch and I'm going to create just some knock screws, right? 20. So those there are representing the screws that are coming down. And this little method here is going to help me visualize the assembly getting on and off, because I want to be able to sort of slide in. So this one can easily be a slot. I've got no problem with that. Whereas these two, if these are slots, I can't get the screw head down unless I have a really big gap. So that becomes like a keyhole type arrangement. We could potentially do that. Could be really neat. So how that would look, let's just do a quick little section view here. So now let's convert these holes to slots. The first one down here, very straightforward. I'm just going to draw a slot like this, okay? And we're just going to cut out this material. So that's what we're doing with this shape. How far are we going to move this slot? Well, not too far. What I mean by that is how far do we want the movement to be when we're putting these on? So set fitting, slide across, lock on. Might be something like this. That could work. And we could sort of repeat that on this one down here. And to do that, I can just select these two slots and just make them equal slots and then do my second hole. So this is my clearance hole. This is like my keyhole. And now I'm not going to trim away my sketch here. One thing you'll find when you trim away slots, you'll lose like some of the constraints that are actually keeping that as a slot feature, right? It'll just like lose a lot of that stuff. So we don't want to do that. I'd rather just keep the sketch contours there and just select the extra contours to cut away. Now it's a little bit annoying, but it only takes a few seconds. Just going to click these areas. I'm done. Now, is that adding any weakness to our part? Well, potentially down here on this edge, like that's getting pretty close. And are we slotting in the right way? Does this hole need clearance as well? Potentially it does. Like if we delete this for a second and we make these slots equal in length, and then we put another one of these clearance holes here, what kind of material is that going to remove? Is that going to be a problem? All right, so we're going to remove all of that. We're getting a little bit weak on this side, on the right. Let's exit isolate. And, just to visualize this, we can offset. So it's 5 in diameter. In total, it's 11. So if we offset 3, so now I'm just pretending we're putting like a washer on top of each of these. I'm not bothering with toolbox parts or assembly just because I want to work very fast. And I'm going to merge these just with these bodies here. And let's just add some color to those bodies just so it's really clear what they are. Pasting a body on there, pasting an appearance to that body. All right, and now we can just visualize how's it going to go on and off. So let's go over here to configurations. We can go new exploded view. I'm going to grab this because this part is the bit that moves, and I'm going to move it across. Now, how far did we move it before? What's the distance between the two holes? That'll tell us how far we need to move it. So we got this one, and the center distance is 8.75. So if we edit this feature, change that. Step 1, 8.75. That's what it looks like when it comes on. So this one's not even close to engaging. Probably don't have to worry about it. I might be able to just sort of angle it in. But this one definitely needs to push up and down. What's that distance there? Maybe it's okay. Let's just do a quick measure. 1.25 millimeters. Yeah, a bit tight. So perhaps, do we need to move the whole thing? What's the distance of clearance that we have between this edge and this edge? 7 millimeters. So we've probably got a bit more room. So we've probably got 12 millimeters instead of 7 here. So we could easily move everything up, which means we could move this position, which was previously on the origin. But if we just move it up like this, let's say just move it 3 millimeters. Well, that's going to give us the extra thickness we need on that bottom section. Can it? Don't have to worry about that little corner. In fact, I'll probably just cut that off. Right. So I'm just going to do rectangle here, cut through. All right. So that's smoothed off. And then the rest look okay. So this gives us like the basic shape now. We know that functionally that should work. Now we need to add a bit of strength to it. And then we need to add, we can add some finesse, some design styling to get it to sit nicely. Because at the moment, this is kind of like it's curved one way, but it should actually curve the other way. We might want to tweak that. So what do we need for strength? Well, we probably want some sort of rib that comes through the middle of the whole thing. And I'll probably want to cut this top corner off. So I don't need all that extra material. So let's start by doing that. And let's increase that angle, increase that distance. Yep, that's good. And now for strength, we can add a couple of ribs. The way I might do that is to sketch on this face, and I'm just going to pick some locations and a distance. I'm not doing anything that fancy. I'm going to do an extrude. How do I want to do this actually? Yeah, I'm going to close the shape. So I make it into a triangle, and then I'm going to do an extrude, and I'm going to give it a 3 millimeter thickness. I'm just going to offset the location. So let's say 80 millimeters. Looks pretty good. I just want to merge it with this body. And we want to repeat that. Let's just do another extrude, and let's try 40 millimeters. Looks pretty good. I'm not worried about it being perfectly symmetrical. The whole thing's hidden away under the desk. I just need it to function. Now, the length at the front, I think we could probably reduce that. So what happens if I take this down to 105? Okay, it's still moving mid-side, but it's the back end that I actually want to be locked into position. So that's to do with this sketch here, and this being from the origin. I'm going to change that reference, and I'm going to make it so this hole is coming off the rear at 10 millimeters. Now, when I change the length of the entire shape, let's say I reduce it by 5, all right? That same edge and those holes are moving as one. Now, I can see my issue with a rib, so I'm going to bring the rib in, okay? And that looks better. Now, that's giving me good strength from this wall to this wall, but nothing at the bottom here, so I'll have to address that. And because my headphone's going to hang on this top section, I probably want to leave that area, so I might actually do something on the outside. Now, to do that, we could just edit this sketch, and I'm going to try something like this, not with a sketch on that side, but maybe one on this side. Let's try it another way. Sketch there to there, and sketch here to here. I'm going to convert these edges. Just going to convert these two edges. Yep. And I'm going to get rid of that one, and then I'm going to trim away some sections. So I don't need that, or that. Make that bit tangent. And let's add some dimensions. 15. Let's get this one and this one tangent. And should I... No, leave it there. So trim away that end bit. And then this one here. How should we do this? Maybe make these two equal. Okay. And trim away that section. So now I press OK. I'm going to get 2 extra ribs on the bottom, giving support. All right, let's do a check to see if our holes are in the right place. I'm going to do a new drawing, blank A4 drawing. Do a model view. I'm just going to grab that model, and let's just do a top view. We'll make our scale 1:1, and we will just put a dimension in here so I can check. Once I've printed it, I can measure that before cutting it out just to see if it's in the right spot. So find my printer. Now I've got this issue. It prints at the wrong scale that I haven't been able to resolve yet. So I just need to increase the scale to 103 to make sure I'm getting it 1:1. Print. All right, we're going to print out. Do a very quick check of dimensions on the print. All right, so I've managed to get that to the right scale. Do some cutting out. What can we see on this? All right, so there's my part. Now the hole locations, I've got a cutting mat, and I did have a nice. All right, it's not beautiful, but all right, you see how that relates to what's on screen? Okay, so I've got my shape, got my slot, keyhole slots. Now I can just fit it underneath and see how that goes. All right, so I'll just grab my bracket and put it up here. You can see I can fit through those keyholes. Now this one's got a bit of a tear in it, and I think I can expect that when I get over those, I'll be able to slide it in just like that and tighten up those holes, and I'd be pretty good. Yeah, I think my measuring looks really reasonable. All right, now we might find maybe I'm 0.5 millimeter off, but I think we'll get that in a 3D print. So let's go to the next stage. All right, so that's a worthwhile exercise, because if we found there was anything in particular wrong, well, we could spend some time and fix it. Do another prototype, do another print, and see what the problem is. So now we can touch this up a bit. So let's do that. I'm going to add some strength to some of these holes. I do have to be wary of the flat that's going to be required there as I pull it in. So I might not want to do too much on that side. In fact, I may want to move away from those holes entirely. I didn't give myself a lot of space, right? But if I did this at 66, just push them out a little bit. Even then, these do not need to be centered, like this one here. I can delete that and just move this across to this side. Let's go 8, a little bit less on the side, right? Now that's giving me more space on that wall where I can add a fillet, for instance. Internal fillet. 6 looks pretty good. Maybe 5. And let's put that before these ribs. Just gonna go up there, Put a 5 there. We'll do the same on the bottom, and which means if we keep a 3mm wall thickness, 3mm, we're going to print pretty solid. That should be fine. 3 plus 5 is 8mm for our external radiuses. Again, just drop that up for those ribs. We'll have to change that rib, but that's fine there. And I'm also inclined now to get these ribs in the center. So I want this one 32mm from that edge. This one needs to be 8mm closer. So I just remove that, 32. Now that bit that's hanging off, just going to get rid of that with a delete face tool. So it just trims that off. Or better yet, I might actually just change the height of that one. Instead of being on this midpoint, I can drag that in, give that one a dimension, 40. Now I don't need that. Let's just delete these relations that aren't working for us, these dangling ones. Make some adjustments. Okay, good. So I can go to there, merge that. All right, so those errors are gone, and now I've got some fillets on the inside faces. Let's clean up these outer edges here. I'm just going to do that with a larger radius, because I suspect we don't have to do too much to this, like for that to work. That's only 105 wide. So if I've got 105mm, okay, that's this kind of section here, 105, that's being flat. It's going to sit quite high, actually. So we want to reduce that. So we probably want to reduce that to something like 60. Okay, so how can we do that? Well, first let's drop those fillets back, and then let's try chamfering it. So on the curve, doesn't really want to do it. We'll try on a top plane sketch. Now there is, under there, is a slight wall that's behind it. I think we'll be far enough out. We don't have to worry about it. I'm going to draw this kind of weird shape. We'll see if it works for us. Just to reduce the width on the edges, let's get that down 60. Let's give it a radius, also 60. Do a cut through. All right, now we've still got the ribs there, looking good. And add the fillets back here, here. Also at the top, just smooth up these edges. And then second fillet here, smaller, 5, 5. Just getting rid of the sharp edges that we've got. Leave that one to the back. All right, now, here's the question. Is this enough? You know, is that going to hold it comfortably? Did I make it wide enough? 35 from this edge, let's say from this edge to this edge. We've got 36, so I think this is enough, right? I think we're looking pretty good. So let's just keep this body. Let's just clean up our ribs slightly, a couple of radiuses. It's just going to go a long way to just, refining the part, taking the sharp edges off. All right, there. Okay, so that's all looking pretty smooth. 3mm, solid wall everywhere. It's not holding a lot of weight. I think this is going to be pretty good. So I'm going to save this now, and we'll jump over into BambuLab Slicer, Bamboo Studio, to set up the 3D print. So in this first attempt at slicing the product, what I'm looking for when I first bring an object into the slicer is to try and find the optimal arrangement to minimize supports and get the best results for surface finish quality. In this example, I thought I would start with flat surface on the bottom, okay, where you can see where the keyholes are. But very quickly I could see that the supports, particularly the standard supports, were going to be quite substantial going up the top, and also that the print time would take quite a long, or that the print duration would be quite long. So decided here to print it only on the plate size first, so I could check the fitting, do a double check at the fitting before we commit to the full 4-hour print.
The print was going to take around 3 to 4 hours, but I could print something like this in about 20 minutes. It's worthwhile, take the 20 minutes, take the extra half hour to check it fits before completing the full print. So let's have a look now. Up here, I can show you exactly what we're looking at. You can see those 3 screws right there, and you can see my part here. And the whole intent of this is that I can just push it over those screws and those washers. So without taking these off, I can get that in there. And look, that's a really nice fit. Let's give you a closer view here. So you can see keyhole, slot, and you can see the fit. And that's really, really strong. So that gives me confidence now to go ahead with the print. So I'm just going to re-slice it, do the whole thing, and we'll come back and see how it looks at the end. print is completed. So we've got a bunch of supports in. I use tree supports so that it's minimal supports actually on this surface. Hopefully they peel away pretty nicely. I did have a thought that while this was printing, that perhaps this shape here on the bottom, perhaps I should have had a bit more curve to this. So we'll see how it fits. If it's no good, we'll just go back into CAD and just change that again. So you can see here the white material, that's the support PLA. So it should be nice and easy to peel off, but you never really know until you get there. Like these, because it all kind of depends on the angle and, you know, my experience anyway. Yeah, that's pretty good everywhere. You just have to clean up all this surface now. This is the bit that's left. All those supports have come away. I'm just left with the support interface PLA and this bit here on the back. That side's done. Now it's just unfortunately the inside face where I hanged. So before I spend all my time clearing that away, let's just see if this works. Now, it's probably going to hold okay. Probably could have made this up a bit more. I think the size is fine. I think the fact that it doesn't have a curve, that part then can have the rough side underneath and a nice smooth shape on the top, and I can actually give it a bit of a curve and a lip on the top. All right, and that's just going to slide over here, and that should give it a nice finish.
All right, hey guys, we're back, and as I saw on the video, not able to get all the support material off this face, and it's a bit rough. And we've got a bit of clearance as well. Here I've got this photo that shows what we're looking at, and I probably should have done this, you know, before the original 3D print. Yeah, is what it is. So we can actually take this as a reference and bring it into our file. I've already got the file here, so all I'm going to do is tell my right plane with a sketch, and I'm going to go Tools, Sketch Picture. I'm going to browse for that file. And now with that file open, I'm just going to hit low resolution. I don't need it to be high res, and that's going to put it in on that right plane. And then I'll be able to scale the photo to a 1:1 size, and then just use the curve as a guide for the new part create to slide over the top. It's loading. So the image is in. Now let's change transparency. Let's rotate the image the other way, 10 minus 90, and then we can reposition and just drag down the scale. So you've got to drag down quite a bit, and it's only intended to give us a guide, right? You can see here, it's going to be a pretty reasonable guide to give that curve. Something like that. Press OK and OK on the sketch. Now it's just there as a reference, and on my right plane, I'm doing new sketch. I'm just going to put in a curve is roughly falling like that. I'm going to pick dimension from the origin, and I'm just going to drop it down ever so slightly. These 2 points horizontal, midpoint vertical, put a dimension between these two, and then a dimension for those 2 lines like that. Okay, now I've got a fully defined arc. It's going to give me a bit of a guide. I can hide this sketch and say, okay, so that's what I'm trying to get. So I want to build a part that's going to fit onto this, somehow snap on, and feel that curve. So let's try that now. Thinking the best way to do it might be coming in from this side, snapping around these 2 edges, and then just sitting on this top face. Don't have to glue it, anything fancy. The hardest thing is just matching the curves and giving a bit of clearance to the rough 3D print. Let's put that shape in. Let's use this as a surface. That's fine. Let's then, how should we go about doing this? Probably just change the design and alter the 3D print so that we get it this way up. I'm tempted just to do that. You and print it this direction. Just remove these ribs on this side. So it's got a flat face there. It's probably going to be a lot easier. Let's redo it. 3D print. Let's have a look at what that design would look like. I'm going to save it as a version 3. And then we're going to roll back a few steps to make that change. Okay, so first change is this sketch here. This has to completely change. It's not going to drop there. It's going to be equal length. It's going to come all the way down here. That side is going to change. Actually going to lose this line. And there's a tangency here that I want to remove. Let's just stop that one. That's because they share a center point, right? So this one can have. Let's delete that edge. What I'm going to do is have a line here, which is going to be vertical, and still have this tangency here. All right, so let's put those back to tangent, and then we're going to merge these 2. Let's give that an angle. So if it's 80, it's going like that. That's still giving it some support, and then we can change this dimension. So instead of coming out the back, it's just staying flat. That's probably enough. How's that instead? Right, so it's still giving some support, but now we can print it like this. Yeah, much better. Much better. Now while we're here, Let's roll this down, roll this sketch up and this one up, and we roll above the fillets, and then we can see this curve. And now what I'm going to suggest is we put that sketch surface in there as well. So we see this surface extrude is here, and then I'm just going to edit this to offset the direction so slightly. So I'm going to see if I can replace face. I might not be able to. So replace face lets us change this face by selecting this surface. But I think because it cuts through the edges, it's not going to work, right? Like that would be a really, really simple solution, but we have to change the curve a bit for that to function. Because if we look at this side view here, you can see it's actually too big on the bottom. So maybe if we cut in more, maybe that's a solution there. So this cut, let's completely change this. Now, this may weaken our design somewhat, but could be for the best. Let's go to the bottom view. Let's drag this to this point, all right? And I think the change that we're actually going to make is bring this back, put a line in here, make it so that this line actually joins up with this point, and change this radius. Something else we need to change. Delete this one. There we go. So we're going to make those points vertical. We still want this to be 60, but how we're going to change it is end dimension. So this side here, that comes down, and this one will just control its own dimension. So like 80. That. Now when that cuts away, that's this dimension here. Just going to cut that a little bit higher. You can go up to that vertex. So in direction 2, going to go up to vertex, which is this. All right, now we're getting a nice sort of shape. And I can change this here. I can fill it and cut that away. I'm not worried about that at all. In fact, we might even go up a little bit higher. Something like this, or even higher still. Not that high, maybe 40. Then we can put in a fillet here. It's going to bring that edge down like that. Okay, so it's sort of smoothing the shapes. Now this surface covers this face, so now we can replace it. We could go get rid of that fillet. Let's drag this sketch up. So drag this sketch up, drag this surface extrude up, draw back above this fillet, cut, boss. So these fillets can drop down or not, because let's see that parent-child relationships. Dynamic visualization. So it's here, I'm going to apply this. So this boss extrude, this cut, it's this fillet we want to move. So all of those are child to this fillet. So these purple lines here, all right, sketch 9 and sketch 10 is linked to those. So I can't move it above that face. But let's say we just move it a little bit higher, because we've still got clearance, right? So this sketch that's here, if we just change the dimensions of this so that it's all controlled by the height, 10 millimeters. All right, what that means is I can press this sketch, I can lift this up. I'm going to lift it up so it's above that radius. A little bit more. I can do replace face this time. Tops these two faces with this. Oh no, that has a blank. Try again. Why does it want to replace? There we go. Now we have our curve. You can see the whole thing looks quite a bit different now. We want to draft out that face. So let's go to features draft. Just change this angle. It's coming out. And I'm wondering if in doing this, we should really change this shape, this original shape here. Because we kind of want that curve actually running across this now. It'd be better as a sweep, in fact. And all these ribs, get rid of them. So could we do that without destroying our model? Probably, because they are unrelated. So if we just move this up, for instance, it's at the origin. That is troublesome. And the whole thing is controlled by it. But if we change it, was 4, let's make it 12 up that way. Let's change this to back from the origin. Let's keep that as is. Give it a radius of 50. All right, so what we're trying to do is maintain everything on the top, but just change the shape at the bottom. It probably should just be flat, and instead I move that shape afterwards. So let's delete that sketch. Let's make this for construction. So it's now included. Now let's see how this impacts our model. So I think all here and here is fine. We'll leave this fillet. We'll come back to that chamfer. What we really want to do is get in this replace face business. So we have the extruded shape here. Let's drop this back down so it's all underneath. Change its cut. At 60 is fine. We're going to change this one to 70. Then we replace the face. Okay, so that's good now. And then we can do the curve. So on our front plane, we can do a sketch. And now this is where we put that curve back in. So if you remember what it looks like, it's like this. I'll actually change it slightly. So again, a little bit of the lip. And how wide is this? Probably want that to be like 38. And from here to here, that's 3 millimeters. Let's go, 38. Then make that 41, not vertical. Give it a little bit to the side. I know we're doing rather drastic changes, but that is all part of the game. It's not going to be very high. And the left distance between this and this, it's not going to be much. So let's create a shape, closed shape, and we're going to use that closed shape as a swept cut. And our path is going to be this curve here. We're going mid-plane. Just, you know what? It's an example of a swept cut I've been looking for in my projects, but that's pretty neat now. This cut needs to change. It's just lost references. It's vertical, and I didn't reconnect these, but I've still got error. That's all good. It's fully defined. Let's remove that delete face. These ribs and these ribs, let's try and bring them down. So we still want to do the ribs, but what we're trying to do is just get them out of the way, and same with the rest of this stuff. So at 1, just get it lower so we can get this part done beforehand. Now what's happened here is we've got our surface doing our cut with our shape. It's lost the body that it's doing it on. So it's not true, blind, 40 to actually 2, it's gone. Right? So that's the issue. Just flipping the directions around. Now we can replace face, and now we can cut sweep. Right? Now we're getting there, yeah? And we can shoulder remove the material. Let's see how this works. And we want the back face as well. That one. All right, so now it's removed that for us. We can just delete face, fill in those flat areas, and clip out the shape that we want to put back on. Now we've got this. I'm just going to draw this shape here. And what that's doing is it's going to close up and give our leak. The profile's going to be this one. We go mid-plane. Okay. But if we move this out, then we'll be able to know it. Okay. Finally get to a smooth result. Now, unfortunately, that overhang is going to require some supports. We might be able to get rid of that. That was a 3 mil radius. Was that the dimensions we were working to earlier? Let's see on it. So let's change this one back to 5. Now I've got errors again. Just separating the delete face features, bring the fillets down, add them back in. Okay. Inside fillet, outside fillet. This shape is looking a lot better now, and I think hopefully going to be really nice to 3D print. Yeah, it's not a perfect model, but it's not bad. Our ribs are going to be more difficult, but you know what? I'm wondering if we even need them on the bottom. The shape here, the constant wall thickness. We're not carrying a lot of weight. I think maybe it's going to be okay. Maybe it is not required. Now, these large fillets were here. On these edges, we see as we bring this down as well, it's going to smooth those off. A couple more edges here. And fillet here. Looking good. Keep the whole body. And then small fillets from the edges. So that's the ribs. And then one final fillet way around the edge. And that looks like a much better sort of shape. If we go back to our original sketch, I think that'll fit pretty well. We'll probably bump that up a little bit, but as far as the height, yeah, this is looking really neat. So save, export, we'll splice again. I'll make sure I take you through that this time, and then we'll put it on the printer. Now, this time with the print, when we bring in the second version or the third version of our headphone holder, we know now that we've designed with the 3D printing in mind. So we've rotated the whole design 90 degrees. So the flat surface is now the back, which means that bottom face, which had all those support material stuck to it in that first printed version we did, we no longer have that issue. And we can see that playing out with the supports. We're using tree supports. There's only a minimal tree sort of on both sides to support that curve edge there. So a much better result. It's going to be much easier to clean up and pull apart. So yeah, let's see how that turns out in the print. No problems here with the print. You can see very straightforward. You can see the smaller trees over on the left and in those holes. Okay, they're supporting the keyhole areas that we've made. The larger trees that you can see at the front and growing under that curled area, they're all to support that front edge. I could probably almost have printed without those, but no problem here keeping those included.
Here's our updated version. It will supports. Pretty neat. Just put it on this side, on the inside. You can see how easily these supports come off compared to the last ones because there's not nearly as much, but part still feels relatively strong. But there's supports here. It's probably not going to be an issue at all. There's this tiny row here on the backside underneath. You can probably scrape that off. And then these ones here, fold, that'll edge there. I'm just going to put a knife here like that. Take those off. It's going to be done. I think it looks a lot better. So again, that's good. Nice and smooth. Good result.
Hey, thanks for watching the video all the way to the end. If you enjoyed it, please like and share. If you've got any suggestions for other content, leave it in the comments below. If you haven't already, please subscribe. And there's some other videos here. Check out. Thanks.